All right, welcome you guys. Today we are going to talk about using the unit circle. So last week we learned how to make the unit circle and figure out all those points along the circle. Remember the unit circle, just a circle with a radius of 1 and a center at 0, 0. Using special right triangles, we were able to build it out and then make connections, okay, between cosine and sine of those angle measurements to find the points on the circle. We also talked about converting degrees into radians, and today we're going to use both. You know, with a bigger focus on radians, we really want to start getting used to that. It's the new one, and that's what you're going to be using as you advance through pre-calculus and calculus. All right, and so let's go ahead and get started. All right, so here we're looking at each of the special right triangles here with the coordinate points given to us. So when the reference angle is pi 6, okay, right, what is the point? Remember, pi 6 is the same as 30 degrees, okay, so that is the x is rad 3 over 2, right, and the y is 1/2. Again, we get that. Let me go ahead and get my pen open. We get that because if this is 30 degrees, right, the side opposite 30 is half the hypotenuse. If the hypotenuse is 1, this has got to be 1/2. All right, and then the side opposite 60 is that times rad 3, so it's rad 3 over 2. Okay. And so that's what we get there. All right, and so that means that x, right, along the x-axis is rad 3 over 2, and up, okay, there is 1/2. Do that for all the other ones as well. I'm not going to go through all the work again. But one thing that we did learn at the end of last week is, okay, so if I ask you what is cosine of pi 6, all right, so you're looking at pi 6, cosine is adjacent over hypotenuse, so it's rad 3 over 2 over 1. Okay, and so that's what we need to be able to do. And if you guys remember the connection we made, and we'll look at all the cosines again when we're done with this page and see if we see that connection again. But remember, that's just the x value. All right, what's sine of pi 6? Well, that's opposite over hypotenuse. That's just 1/2. Okay, so over here, again, right, this is going to be rad 2 over 2. This is going to be rad 2 over 2. So when I go, what's cosine of pi force? Cosine of pi force adjacent over hypotenuse, so rad 2 over 2 over 1, so that's just rad 2 over 2. And then sine of pi force opposite over hypotenuse, again, same thing, rad 2 over 2. Cosine of pi thirds, okay, so again, if we fill this out, okay, this is 1/2 here. This is rad 3 over 2. Remember, pi thirds is 60 degrees. So cosine of 60 degrees, okay, our pi thirds adjacent, so that's just 1/2 over 1, so just 1/2. And then opposite sine, opposite over hypotenuse is rad 3 over 2. All right, so if we take a closer look at our answers, all these cosines, cosine of pi 6, rad 3 over 2. Cosine of pi 4 is rad 2 over 2. Cosine of pi thirds, 1/2. Those are my x coordinates. Okay, and what about my sines? My sines, okay, 1/2, rad 2 over 2, rad 3 over 2, those are all my y coordinates. All right, and so the advantage of being able to create in the unit circle or know the unit circle is it allows us to easily recall these specific cosine and sine values of these given angles. Okay, and these are the ones that we should know off the top of our head. Okay, pi 6, pi 4, pi thirds. Right? That's 30 degrees, that's 45 degrees, that's 60 degrees. We should know all those. All right, and so if you know them, then we can go all the way around the circle, okay, at those given increments, at those rotations. All right, we're going to talk about that in a little bit more detail here coming up next, okay, in a couple slides. All right, open-ended question. And I just gave you guys the answer to this. Okay, how can you use the coordinate points on the unit circle to help evaluate the following trig expressions? Cosine theta, sine theta, and tangent theta. Okay, and so, well, cosine theta, all right, cosine, I guess I can't really type in theta here. Does it give me math? Does not look like it gives me math symbols here. Okay, cosine, so we'll call it x for now. Cosine of x, I can't do that. Cosine theta is always the x coordinate. Sine theta is the y coordinate. Okay, and then, whoops, the one that's a little bit tricky, okay, which I didn't even put on the last slide. We actually have another slide over here coming up to help with this one specifically, is tangent. Okay, what is tangent? Well, if you think of SOHCAHTOA, tangent is opposite over adjacent. Okay, and so here, if you remember, sine is just, it's opposite over hypotenuse, but hypotenuse was just always 1. Okay, so sine is technically just opposite in this case, and cosine is just adjacent. Okay, and so opposite over adjacent, okay, means that it's just sine over cosine, which, right, it means it's the y coordinate divided by the x coordinate. All right, so another way of looking at it, thinking about it, is tangent equals sine over cosine. There's another way to think of that, okay? Or just y over x if you're looking at the coordinate points. All right, so now we're back to that same picture, okay? And then we want to do tangent of 0, tangent of pi 6, tangent of pi 4s, tangent of pi 3rds, and tangent of pi halves. Okay, and so we're just going to be using our knowledge, okay, from that last slide, okay, that tangent is y over x. Okay, there could be some issues though, as we're going to see here coming up. Okay, issue number 1, okay, is that the denominator cannot be 0. Okay, and so if the x coordinate is ever 0, right, tangent is undefined. All right, and then the second issue, still with the denominator, is we're not allowed to have a radical in the denominator. So when we write our most simplified unique answer, we got to make sure that we don't have any radicals in the bottom. All right, so let's take a look at tangent 0. Okay, so what is that? If I'm looking at the circle, that's the point 1, 0. Okay, so y is 0, x is 1, so tangent 0 is 0 over 1, or just 0. Okay, tangent pi 6. Okay, so when I do this, if I write this out, it's 1/2, right? That's my y over rad 3 over 2. Right? But I can't leave my answer like that. Okay, so when you're dividing by a fraction, okay, you are technically multiplying by the reciprocal. So I'll do a little side work down here. Another way to do that is you're going to write 1/2 times 2 over rad 3. Okay, and if you multiply that together, those 2's cancel out. You get 1 over rad 3. And then, again, just another reminder, we can't have a radical on the bottom, so I got to multiply the top and bottom by rad 3. And that gives me, on top, rad 3, on bottom, just 3. So the tangent of pi 6, okay, tangent of pi 6 is rad 3 over 3. Let me erase this up here. Just write the answer in. Rad 3 over 3. Oops, I don't know why I did that. All right, so again, we're dividing fractions, so we multiplied by the reciprocal that and left us with a radical in the denominator, so we had to rationalize the denominator, and we ended up with rad 3 over 3. So tangent of pi 6 is rad 3 over 3. Okay? Tangent of pi 4 is going to be a little bit easier because here x and y are the same thing, right? So whenever you're dividing by the same thing, that answer is just 1. Okay? Tangent of pi thirds, okay, again, y over x. Okay, this one's going to be a little bit easier. Change colors over here. Okay, and show you the work. Remember, so it's rad 3 over 2 divided by 1/2. So again, if I do all my work, I got to multiply by the reciprocal. Okay, the 2's are just going to cancel out. So again, what I have is I have rad 3 over 2 times the reciprocal, 2 over 1. So you can see that the 2's are going to cancel out. And then it's just rad 3. So tangent of pi thirds is just rad 3. Okay. Pi halves is 90 degrees, so that's this point right there. What's that point? That's the point 0, 1. Okay, what's the issue with this point? Okay, the issue with this point is x is 0, right? So if I write it as y over x, right, it's 1 over 0, right, which is undefined. Okay, so there is no tangent of pi halves. We just write UND, undefined. Okay, so our big takeaway, all right, is if we have the unit circle, how do we use the unit circle? The unit circle gives us all these ordered pairs that are on the unit circle at given angles, okay? And so our big takeaway, let me clear all my work here. Our big takeaway, actually, let me just write it, okay, is that sine of theta is y. Okay? Cosine of theta, that's a theta there, is x, and tangent theta is y over x. Okay? So if you have the unit circle in front of you, right, you should be able to find sine, cosine, and tangent of any angle on the unit circle. All right. If you don't have the unit circle on you, you should be able to create the unit circle, or at least the first quadrant of the unit circle, and then based off of that, be able to fill in the rest. Okay, because we know all the numbers are the same. You just have to worry about the signs, positive, negative signs, and what quadrants. Okay, and then it's very easy to find sine, cosine, tangent of any angle measurements on the unit circle. All right. So as I just mentioned, right, if you know the first quadrant, you should be able to do all of it. And so that's what we're going to focus on again, right here. So this chart is for your notes, okay? This is what you should know. This is from the unit circle, right? At 0 degrees, okay, or at the angle measurement of 0 radians or 0 degrees, doesn't matter which one, it's the point 1, 0, right? When theta is pi 6 or 30 degrees, okay, it's the point rad 3 over 2 and 1/2. At pi 4, so 45 degrees, it's rad 2 over 2 and rad 2 over 2. When it's pi thirds or 60 degrees, it's 1/2 in rad 3 over 2. And when it's pi halves or 90 degrees, it's 0, 1. You should know these points. You should be able to create the first quadrant of the unit circle, okay, using your knowledge of 30, 60, 90 triangles and 45, 45, 90 triangles, and get these points. If you can remember them off the top of your head by memorizing the unit circle, okay, even better. All right, but you should be able to always create that first quadrant of the unit circle. Now, that's important because every other angle on the unit circle kind of relates back to these angles. What we do is we call these angles the reference angles. All right, so 0, pi 6, pi fourths, pi thirds, and pi halves are all considered reference angles. Okay, and you see it here, it's theta with the little subscript r for reference. Okay, so whenever you see theta with the subscript r, they're talking about the reference angle. Okay, and it could be associated with any theta that's bigger than pi halves. Okay, so right, the first quadrant ends at 90 degrees, so anything bigger than 90 degrees can be related back to a reference angle. Okay, because we know everything is symmetrical in there. All right, so for any angle theta in standard position, okay, the acute angle theta formed by the terminal side of the x-axis is called the reference angle for theta. All right, so let me try to draw that out here for you guys. Don't have a lot of room here, but if we have the unit circle, and we have okay, the angle in standard position. So what they mean by standard position, okay, is that it always starts on the positive x-axis, okay, and it's going to always move from there, okay. It's measured this direction, okay, counterclockwise, okay. So standard position is the vertex is at 0, 0. There's always one side of the angle that goes along the positive x-axis, okay, and the angle moves counterclockwise, okay. And so let's call this angle 135 degrees, okay. Or if it was in radians, it'd be 3 pi fourths, okay. 135 degrees or 3 pi fourths. What's the reference angle? Okay, so what they're saying here is formed by the terminal side and the x-axis. What's the terminal side? That's the side where it ends. So it's not the side on the positive x-axis right here. Okay, and so what they want to know, if I just change colors here, is now what is this angle measurement? This angle measurement will be the reference angle. Okay, so that's 180 minus 135. So that's 45 degrees. So the reference angle here, okay, theta subscript r, right? Not a very good theta. Okay, is 45 degrees. All right, why is that helpful to know that? So now, if I say, what is the cosine of 135 degrees? Well, if I know what cosine of 45 is, okay, then I know what the cosine of 135 is. Okay, the cosine of 45, or pi fourths, is rad 2 over 2. So cosine of 135 is rad 2 over 2, but since it's in the second quadrant, x is negative there. That's why it's important to know that the second quadrant is negative positive, right? Third quadrant's negative negative. Fourth quadrant's positive negative. And the one I skipped, obviously the first quadrant is positive positive. So when you using the reference angle, everything's always positive. You just got to make sure you get the right sign on it, if it's cosine or sine, if it's the x or y value. Okay, so we're going to just take some time practicing finding reference angles and using our understanding of the reference angles, okay, to know. So if you could just remember these 5, all right, then it's easy to derive the rest of the angles from the unit circle. All right, so here we just want to find the reference angle. All right, and so here it's given in degrees. All right, so here's the angle that's given is 330. The reference angle is the angle given from the terminal side, okay, what's the terminal side here? The terminal side here is this side right here, that in the x-axis. What I want to know is how big is this? How big is that? Well, it's just going to be 360 minus 330, because we know that 330 plus what? It's got to make that whole 360. So the reference angle here is just 30 degrees. Okay, so that's my remember my theta r, my subscript r here. My reference angle is 30 degrees. Right. And then we want to find the associated xy point for that, okay, for 330 degrees. All right, well, we know that 30 degrees, okay, right, is rad 3 over 2, 1/2. Okay, so that's 30 degrees, but I want to know 330. Okay, what's 330 degrees equal on the xy coordinate plane? Well, that's down here in the fourth quadrant. So my x is positive, but my y is negative. So what I'm looking for here, when it says find the associated point xy on the unit circle, right? You got to make sure you get your signs correct. Okay, the reference angle tells you what the x and y are, and then the quadrant tells you what their signs are. Okay, so the reference angle is only going to give you the absolute values of the signs. We need to use our knowledge of the four quadrants to get the right positive or negative sign. All right, so really fast, let's do 120. So again, what they want to know is what is this angle right here? So it's got to add up to 180, so that's 60. Okay, so the reference angle is 60 degrees. Okay, but we want to know the x and y coordinate of 120 degrees. Right, so what is the x and y coordinate of 120 degrees? Well, if it was just 60 degrees, okay, it's 1/2 and rad 3 over 2. So we're in the second quadrant on this one. So that means my x is negative and my y is positive. So at 120 degrees, the x value would be negative 1/2. So cosine of 120 would be negative 1/2. And the y value, so sine of 120 would be rad 3 over 2. All right, and that's using or finding the reference angle, using our understanding of the reference angle, and then our sign knowledge of what quadrant we're in to finish off the problem. All right, so here's the same exact question, but now they're giving it to us in radians. All right, so all right, we just got to get used to this. Is again, this is going to be more useful, more helpful. All right, what do they want us to find right here? Okay, the reference angle. So they want us to find this angle right here. All right, so if this whole thing is pi, right, what is missing? So I have 5 pi 6. What's missing? That's pi 6. All right, and so that's my reference angle. Okay, my reference angle is pi 6. What is the point on the unit circle that is associated with 5 pi 6? Okay, so now we just got to think back. Okay, what is pi 6? Okay, pi 6 is 30 degrees. Okay, so what do we know about 30 degrees? If we can remember correctly, it's rad 3 over 2 and 1/2. And now we look at what quadrant are we in? We're in the second quadrant, so the x has to be negative. Okay, so the x and y coordinates for 5 pi 6 are negative rad 3 over 2 and 1/2. Okay. And then coming over here, 7 pi 4ths. Okay, so what is this angle right here? All right, well, how many are left? Okay, we want to get the 2 pi now. It's all the way around the circle. So 2 pi minus 7 pi 4ths is just pi 4ths. Remember, 2 pi is 8 pi 4, so we're just missing 1 there. Okay, so that's my reference angle. Okay, reference angle is pi fourths. And then what is the x and y coordinate at 7 pi fourths? All right, so remember pi fourths is just rad 2 over 2 and rad 2 over 2. And then in the fourth quadrant, the y is negative. So rad 2 over 2, comma, negative rad 2 over 2. All right, and so that is finding the reference angle. All right, and then the corresponding xy point on the unit circle. Now, a reference angle does not have to be one of the special angles on a unit circle. I could give you a random angle like 107 degrees and then say, what is the reference angle for that? It would just be 180 minus 107, okay? And so, but for our purposes, we're always going to try to give you measurements that work out to be on the unit circle. All right, so with that being said, okay, can we do cosine of 330, sine of 330, and tangent of 330? So we already answered this question, okay? The point 330, okay, corresponds to the point rad 3 over 2 and negative 1/2. Okay, that's what we figured out, okay, 2 slides ago. So what is cosine of 330? Well, it's just my x. It's just rad 3 over 2. What's sine of 330? Well, that's just my y. So it's negative 1/2. What is tangent? Okay, so thinking back to our tangent page, we kind of have done this already. It's y over x, right? And so the 2's are going to cancel out. I'm left with negative 1 over rad 3, which we know we can't leave my answer like that. So when I rationalize this, okay, my final answer is going to be negative rad 3 over 3. All right. Now we do 120 degrees. Okay, we know that 120 degrees, okay, corresponds with the point negative 1/2 in rad 3 over 2. So cosine of 120 is negative 1/2. Sine of 120 is rad 3 over 2. And then tangent, okay, of 120 is just negative rad 3. The 2's cancel out, right? So you just get negative rad 3. So again, the part that is somewhat challenging is what we already had done, right? It was finding the ordered pair, okay, that's associated with that angle. All right, and so if you have a picture of the unit circle, it's really easy. Okay, so right when you get to pre-calc and your teacher makes you memorize it, okay, on all the tests, it's a smart idea to draw the unit circle, at least the first quadrant of the unit circle, and then do the reference angle trick that we just talked about. All right, so you got to know the unit circle to make this stuff a little bit easier on yourself. All right, let's do it with radians now. So same questions as before. Okay, just now this stuff is in radians. Okay, so cosine of 5 pi 6. All right, again, we just talked about this. Remember, that's in the second quadrant, so that's negative and positive. Okay, so cosine is negative rad 3 over 2. Sine of 5 pi 6 is 1/2. And then tangent, okay, again, so y over x, right? We get this one where you get 1 over rad 3, so it's just going to end, or negative rad 3, so it's going to end up being negative rad 3 over 3. Okay, 7 pi fourths cosine. Again, remember 7 pi fourths is all the way in the fourth quadrant, so the x is positive, rad 2 over 2. Sine is going to be negative, negative rad 2 over 2, and that makes the tangent just negative 1. All right. So you guys should be able to find cosine, sine, tangent of any angle that's on the unit circle. If it's given you in 2 degrees or if it's given to you in radians, if it's on the unit circle, you should be able to do cosine, sine, and tangent. Okay, especially if you have a picture of the unit circle, it's super easy. Again, if not, you've got to kind of work your way into it by knowing at least the first quadrant. All right, here's for your notes. Okay, so when I asked a few weeks ago how many people have ever heard of secant, cosecant, and cotangent, okay, and only a few people had. So these are called the reciprocal relationships, okay, or reciprocal trig functions, or trig ratios. So here they are, okay. So secant, abbreviated SEC, is the reciprocal of cosine. So secant theta is 1 over cosine. Cosecant theta is the reciprocal of sine, so it's 1 over sine. Okay, cotangent is the reciprocal of tangent, so it's 1 over tangent. Okay, which also means, right, if you look down here, you could write it as x over y, since tangent is y over x, so the reciprocal is x over y. Okay. Another way to write them is like, well, cosine is 1 over secant. Sine is 1 over cosecant. Tangent is 1 over cotangent. So you can, either way, the same relationship there. They're reciprocals. All right, and again, this is what we just wrote down on the previous one. Cosine of theta is always x. Sine of theta is always y. Tangent theta is always y over x, where x cannot be 0. And so secant is just 1 over x. So if you have the unit circle, okay, just 1 over the x-coordinate. Again, remember, no radicals on bottom, no zeros on bottom. Cosecant is just 1 over y, because sine is y. Again, y cannot be 0. Y cannot be a radical. If it's a radical, we just got to rewrite it. And then cotangent will just be x over y. Again, y cannot be 0. All right, so those are going to be new for us. I had a math teacher that had a saying that I still remember to this day. Is if you're having a hard time trying to remember, okay, does secant go with cosine or does secant go with sine? Where they go? And the saying was, you cannot be too cozy. Cannot be too cozy. You're not going to have any relationship is not going to have 2 cos in it. So if it's cosine, it can't be cosecant because then there's 2 cos in it. So that means cosine is the reciprocal of secant. All right. And then with sine, okay, it's got to go with cosecant. All right. So it can't be too cozy. All right. If you have 2 cos in the same thing, it's wrong. All right, so secant has to go with cosine. And then the tangent ones are obviously easy because they both have the word tangent in it. Cotangent, tangent. All right, now that you have that written down, let's go ahead and see what we have to do next. All right, so we have now cosine, tangent, cosecant. So we have to evaluate using the unit circle. All right, so cosine of 315. Okay, so all right, this would work quicker. All right, so we have the unit circle right here. All right, so we can just jump back and forth. So cosine of 315 is the x value, so that's just rad 3 over 2. Let's change my pen up a little bit, make it skinnier. All right, tangent of 11 pi 6. 11 pi 6 is over here. So tangent, remember, is y over x. Okay, so this is the one where it's going to be 1 over rad 3, negative 1 over rad 3. Okay, which we know that we have to, I'll write it, but then we can't leave it like this, right? So when you rationalize the denominator, you get rad 3 over 3. Negative rad 3 over 3. Okay. Cosecant of 210. So remember, cosecant, okay, is 1 over y, because it's cosecant is 1 over sine. Okay, so 1 over y. So what's 210 degrees? The y value is negative 1/2. So what's the reciprocal of negative 1/2? And that's just negative 2. Okay, so cosecant of 210 degrees is negative 2. Okay, sine of 4 pi thirds. Okay, so we go to 4 pi thirds. Okay, sine is the y value, so negative rad 3 over 2. All right, secant of 270 degrees. Remember, secant is 1 over cosine, right, or 1 over x. Okay, and what is so 270? That happens to be right on the y-axis. Uh-oh, that might be an issue, right? The x is 0. Okay, so what's that mean secant is? That means 1 over 0? What do I write again for that? So you can't have 0 on the bottom, so this is undefined. So you have to put UND. Okay. Cotangent of pi halves, remember that's x over y. So pi halves is 90 degrees. That's right on the y-axis as well. Okay, that's 0 over 1. X over y is 0 over 1. That one's okay. 0 over 1 is just 0. All right, so cotangent of pi halves is just 0. If it was the other way around, if it was tangent of pi halves, then it would have been y over x, then it would be 1 over, then tangent of pi halves is undefined. But this one's okay. 0's on top, not the bottom. All right, so again, for this class purposes, I mean, if you have the unit circle in front of you, all this stuff is super direct and super easy. Okay, the challenge, like next year when you're in pre-calc, okay, the challenge is those teachers really want you to know these without having to pull out a reference sheet of the unit circle to look at, because you're going to be evaluating things so many times that they want you to be able to recall. And so they're really going to drill in. There'll be probably time tests on how fast you can fill in the unit circle. Because at least, I mean, you should be able to make the unit circle on every assignment, so you don't have to pull out a reference sheet, but you can make it and then use what you make. But either way, we got to be able to use it, okay? And it'd be awesome if you know it and can use it. All right, so got an example here. I want to find all 6 trig functions for theta equals pi fourths. All right, so what is that point? The first thing I want to do is I want to know what is that point, okay? So that point right there, okay, knowing my unit circle, it's in the 3rd quadrant, so they're both negative. Okay, the point in question is negative rad 2 over 2, comma, negative rad 2 over 2. Okay. So the first thing when you're doing this and you're asked to find any of the trig ratios of any angle on it, you need to know your x and y coordinate points. Okay. So again, how do you do that? You either look at the unit circle. Okay, you pull up the unit circle, 5 pi fourths, there it is, negative rad 2 over 2, negative rad 2 over 2. Okay, or you remember them, or you go, okay, what's my reference angle? Okay, my reference angle is pi fourths. What's that one again? Okay, so a couple different options to know that. So if I want to do, again, they're both negative. I know it's hard to see that, negative. Okay, so let's just start with the easy ones here. So what's cosine? Okay, cosine of 5 pi fourths. All right, that is negative rad 2 over 2. And what is sine of 5 pi fourths? That is also negative rad 2 over 2. What is tangent of 5 pi fourths? Okay, this is a good one. It's easy, but at the same time, I get a lot of mistakes on this one often. Okay, so it's easy because x and y are the same thing. So when you divide, y divided by x is just 1, right? Now, the mistake is a lot of people put negative 1 because it's in the 3rd quadrant, but it's actually positive 1 here. Tangent's positive in the third quadrant because negative divided by a negative is a positive. Okay, I said all 6. I only did 3. So what do I need to still do? I need to do all the reciprocal functions. So I need to do secant of 5 pi fourths. I need to do cosecant of 5 pi fourths. And I need to do cotangent of 5 pi fourths. Oops. All right, and those should be pretty easy now that we have those down. Okay, this part should be pretty easy because we just have to do the reciprocals of those answers provided to us. Okay, so what's the secant again? That doesn't look very, that's a cosine right there. Okay, so secant is the reciprocal of cosine. So it's just, you take that and you flip it. Okay, but again, got a radical on the bottom, so I got to rationalize it. Okay, and so when I rationalize this, okay, I'm going to end up with negative rad 2. All right, cosecant must be the same thing. And then cotangent is the reciprocal of 1, so that's just 1. All right, so there you go. Again, all I did was I took my answer from above and I flipped it, and then I rationalized it. So you multiply the top and bottom by rad 2. You're going to end up with negative 2 rad 2 over 2, and then the 2's cancel out to give you negative rad 2. And there you go. So you should be able to find any one of the 6 trig ratios from any angle that is on the unit circle. All right, so your assignment is going to be an edge elastic one. Okay, so go ahead and get started on that.